Okay, right, I don't want to keep you all waiting, so let's get started. Thank you so much for joining me this morning. My name is Jo. I'm a maths teacher. I teach at Harris Academy Sutton, where I'm an assistant principal, and I teach, oh gosh, it's already coming up saying bad network quality, guys. I am so sorry. If this doesn't work, then please tell me in the chat, because, you know, I'm in a Harris school and who knows what's going to happen with my internet today. Right, let me start again. So I teach year 8, 9 and 10. I've been teaching maths for over a decade now. And I'm going to talk to you today about teaching in depth at Key Stage 3. Like I say, I'm sitting in my office at Harris Sutton, and as I'm sure you all know, I have no idea whether Teams is going to do the right thing for me today. So if Teams lets me down and suddenly I get kicked out my own meeting, please just bear with me and I'll try and get back in. And if my slides don't do what they're meant to do, tell me in the chat, please. You're welcome to unmute yourself if you want to join, participate at any point, if you want to ask a question or challenge me on something I'm saying, or of course you can use the chat as well. Because I'm at the moment like kind of talking and you're all just silent and I feel like I might be talking to myself, could you just say hello in the chat for me? So could you say what school you're at? That'd be really helpful. So I'll start. So I'll say, hi, I'm Jo at Tatsu. And if you could all do that, then at least I know that you can hear me and that we're starting off all right. Okay, so if you could just all write hello in the chat and just say what school you're at, then at least I know that you can hear me. Yes, thank you, Max. Yay, Elizabeth, thank you. Right, okay, thank you. You know what it's like when you're presenting online and you sort of think, is anyone actually there? Right, lovely. Hello, everyone. Oh, isn't it lovely, all these different schools? It's such a nice thing about working in Harris that we're all over London. Amazing. And I don't know, I'm looking at your names, and I actually don't know a lot of you. I know a fair few maths teachers across Harris, but there's definitely people here who I have not met yet. I used to be on the consultant team, and so I met a lot of maths teachers, but now I'm just based at Harris Sutton and I don't get out and about. Right, lovely. Oh, thank you guys. This is really nice to see you all. Right, perfect. And I have my colleagues, Alyssa and Sarah, who are just sitting down the corridor watching me. So hello, Alyssa and Sarah, you can come tell me if it all goes wrong. Right, let's get started. We're going to talk about teaching in depth today. Okay. So, the other thing I wanted to say before I start is that as well as being assistant principal at Harris Sutton and teaching maths, I also do a lot of tweeting, Maths Gem. So if you're on Twitter, then follow me because I talk a lot about maths teaching. And also I have a blog, resourceaholic.com, which some of you might use to find resources for your lessons. And if you haven't heard of it, maybe check it out because it might save you a lot of time. Okay, right. So teaching for depth. Now let's think about our now I've said Key Stage 3 mainly because I'm talking about Key Stage 3 topics, but this applies to Key Stage 4 as well. When we're teaching for depth in maths compared to when we're teaching for breadth, just think about the kind of the two sides of what we could do. We could take something that we are wanting to teach and we could teach the kind of, introduce it, and then we could go deeper. We could teach a deeper level of understanding, go into a lot of challenge within a topic. Okay, that's when I talk about teaching for depth. I mean that we take a topic and instead of sort of moving on, we go into lots of depth and challenge on that particular topic. The alternative to that is teaching for breadth. So we're teaching a wide range of topics, and what that might involve is, for example, jumping from one topic to another. So teaching a topic quickly, teaching the procedures, moving on, and then teaching another topic quickly, teaching the procedures and moving on. So what I want to focus on is how we cannot skim the surface of every topic. Like this idea of like quickly this topic, quickly another topic, quickly another topic. I've moved away from that side of teaching, which is definitely how I used to teach. I used to jump from topic to topic really quickly. And these days I try and teach in a lot of depth. So I'm going to talk to you about how I teach in depth and why I think it's important. Okay, but I know what some of you will think straight away. There is like a Goldilocks thing happening here. You can have too much depth and you can have not enough depth. Okay, so I don't want anyone thinking that I'm going to sit and tell you that you need to spend half a term teaching fractions, because then we're all like, oh my God, that's too much fractions. Okay, so let me explain what I mean by this kind of Goldilocks effect. So at the one end of the scale, you've got some teachers, you'll all know teachers like this, who flip between topics really quickly. They get through a topic, they move on. It's like, yep, I've done that topic, on we go. And they just keep doing that. They're like, next topic, next topic, next topic. Okay, so they're just going really quickly. They're not building connections between topics. They are giving a very superficial procedural knowledge all the time. And the focus is always on performance. So they're saying, can they do it? Yeah, great, move on. So can they follow this procedure that I've just modeled to them 5 minutes earlier? Yes, move on. Okay, so that's one end of the spectrum. At the other end of the scale, in terms of sort of teaching very quickly and going into lots of depth, at the other end of the scale, you've got teachers who might drag topics out. So they show every possible example for every single topic. It's like every possible different way it can be done gets modelled individually. So not giving students a chance to think for themselves because they're being shown everything. And then this kind of lack of cohesion, so lots of activities. So for example, that would be teaching SERDs and going to the SERD section on resourceaholic.com or going to a website with loads of resources and literally just going through all the activities on SERDs. It's like, let's just give them 12 different lessons with 12 different SERDs activities. Like that's not a kind of how we should approach teaching, just by throwing activities at students. And of course, what this leads to is that topics get dragged out for a long period of time. There's no variety, there's no pace, and the students are really disengaged. So we have two ends of the spectrum, people that move too quickly and people that move too slowly through the curriculum. And we will need to be finding that middle ground where we are going into depth, but we're not boring our students and we're not dragging things out unnecessarily. So we're going to find the middle ground today. I did a survey recently. So I had about 700 replies from Key Stage 3 maths teachers, and 64% of them have told me that they feel like they sometimes teach topics too quickly. Okay, 64% to me is quite a lot. I certainly feel like I teach topics too quickly sometimes. And sometimes that's because I don't have enough time in a scheme of work to really go into depth. But actually, sometimes I teach topics too quickly because I haven't got time to plan them well, because I'm rushing in my job. I don't have time to plan well, and therefore I rush through my teaching. And there's various other reasons that sometimes I feel like I am rushing in my teaching. I think it's something that we like 64% of us, so quite a lot of us, feel that sometimes we are rushing and we don't want to rush, but we feel like we have to rush. Now, it's kind of obvious to say we shouldn't rush. Those of you who read the recent Ofsted research review into maths, really great, useful document about all the things we should be doing in maths teaching, that document sort of stated the obvious. Pupils should not be rushed through content. Like, it is so obvious that we shouldn't be rushing them, but yet it happens a lot. Okay, so I'm going to talk a bit today about why it happens and how we can kind of stop the rushing, but at the same time not go too far so that we're kind of boring our students by going way too slowly. Okay, so I'll talk a bit about those things today. This was a comment. When I did my survey, 700 teachers replied. I got some great comments from people. This is one that a teacher said. The teacher said, "We repeat topics on a number of occasions, but it always feels so rushed that each time the topic is introduced, it's like starting from square one." Now, I bet a lot of you think that's quite a familiar thing. So this is something that lots of us go through, isn't it? So we will say we'll teach percentages in year 7, and then it's on the scheme of work again in year 8, and we do it again in year 8, and it's on the scheme of work again in year 9, and we do it again in year 9. But it feels like sometimes we're starting from scratch every time. Now, that's partly because maybe we haven't done enough in terms of retrieval practice in between, and that's something that's quite easily addressed. But the other reason is that we haven't perhaps taught it in depth enough the first time. So students get this really superficial procedural knowledge. They can do it in the lesson, they can't do it a week later. And that means that when you come back to that topic the next year, they don't remember how to do it because it was rushed through the first time. So really, this is quite a common thing that teachers are feeling. When I did my survey, lots and lots of teachers were saying this kind of thing, like they feel like it's not helpful that they're rushing because it's not helping the sort of future progression for those students. So let's just think about what rushing looks like. I'm talking about rushing, but I actually want you to know what I mean by rushing. And some of you will know what it feels like to rush as a teacher. You know, when you know that students need more time on something, but you stop anyway because the scheme of work says you have to move on. So that's where we have to rush. But have a look at what I mean by rushing and things that teachers who rush might say. So a teacher might say, "Oh, well, my class has already finished the unit on expanding double brackets. It only took one lesson and they could all do it, no problem." So if I hear that from a teacher sort of not necessarily bragging, but a teacher sort of being really like, you know, confident that they were right to spend one lesson on this unit of maths and then move on, then I might sort of wonder how much depth they went into on expanding double brackets. I mean, yeah, you might have a really bright class who might pick it up really, really quickly. And yeah, that happens a lot. Often, really smart students can very quickly pick up the procedure that we're teaching them and have a high amount of success in the lesson. They're literally mimicking what you're doing on the board. They're replicating it. It's all done well. And you think, yep, done, let's move on. So I guess I would say to that teacher, like, did you do stuff like this? Like, you know, with a bit more algebraic challenge. I mean, look at that exercise where you're having to multiply 3 over x and 1 over x, like just a little bit more thinking, a little bit more following, a little bit less following a procedure and a little bit more depth of understanding, because students need to just stop and think for a minute. Or perhaps an exercise like this. Now, I did this one with my year 8s this week, and it did nearly kill them. Like, they found it really, really hard. And my year 8s are a set 2. They're not a top set. They are pretty bright. They are really hard working. And we just did index laws with year 8 a couple of weeks ago. It's the first topic of year 8. So we did index laws, and then we moved on to expanding double brackets. And those topics link together beautifully. But they only link together beautifully if you do stuff like this here. So this expand and simplify task at the bottom. So in that task, you can see that they are multiplying out the brackets and they're using index laws to do so. And what my class really struggled on was, well, you can probably imagine, the negatives caused them difficulties. Things like in that first one, in A there, where they're doing x multiplied by x to the power of -1. And I'm saying, you know how to do this, add the indices, 1 plus -1, and it's giving them 0, and then they're just writing a 0, they're not writing x to the power 0. There's all these misconceptions that I managed to pull out by giving them this task. When it got to the fractions, they're like, oh, I don't know how to do, in question H there, x to the power of a third times 3x to the power of 5 over 3. And they were confused about how to add a third and 5 over 3, something that they've done many years now. They know how to add fractions. In fact, my daughter started doing that in year 3, adding fractions with common denominators. They don't really know much about fractions at that point, but they know how to do that. But yet here they are in year 8, having done much more complex maths, forgetting their basic stuff. So this activity worked really well for me because it was a chance to address loads of misconceptions, do loads of retrieval. So if I had a teacher saying, oh, I finished expanding double brackets in one lesson and I've moved on now, then I would say, well, why don't you go into more depth? Why don't you do a task like this one? I'll give you another example of rushing. A teacher might say, oh, you're still doing areas of sectors. Well, I taught theta over 360 times pi r squared, and it's so simple when they use the formula. So we're 2 units ahead of that now. We're going to have loads of time for revision before assessments. So the teacher's basically saying, why are you still on that topic? I just taught them the formula. They got that, we've moved on, and then later on we're going to just do loads of revision. Like, to me, that's not making good use of students' time. We should be teaching topics in depth the first time round, and we don't have to have ages to revise before the exam if we teach it properly the first time round. So we should be making full use of the time that we're allocated to teach things and not rushing ahead. So I don't teach this formulaically. I don't teach theta over 360 times pi r squared. I teach it by reasoning. But I would say to a teacher who says this to me, like, well, did you go into depth on this topic and did you get them to do questions like these? Okay, because I look at these questions. These are beautiful, aren't they? Lovely questions. I love anything to do with areas of sectors. And it's saying find the shaded area. Now, you can't find the shaded area in these questions without using some reasoning. Okay, so I don't care if you know the formula, theta over 360 times pi r squared. Like, yeah, maybe you can use that here, but you also have to use some reasoning. And it's practice. Not like this is just some random investigation puzzle thing that's not related. This is very much in the topic that we're teaching, but it's going into greater depth and it's giving students the opportunity to reason. And it's saying, yeah, we know a formula, but actually in this question you need to think and you can't just procedurally follow a formula. I have said this before, index laws, I covered all 3 in one lesson. And in fact, I once got a job at my previous school that I worked at in Glyn, which is in Epsom. In my interview, they asked me to teach index laws and I taught all 3 in one lesson and I got the job. So that must have been good. But actually now there's no way I teach them all in one lesson. Now I spend a long time teaching index laws and I teach each of the index laws individually. Now, I'm not saying that's definitely the right way of doing it, but there are definitely opportunities to go into depth which you can't fit into the space of one lesson. So, for example, I mean, this is nothing special. This is just, this is actually an exercise from an old textbook. And it's an exercise from a textbook from, I think, the 1950s, possibly. And when I spotted this one, I thought, you know what? I don't have an exercise like this. This is power law with coefficients, and it incorporates the multiplication law, and it incorporates the division law. So and it incorporates collecting like terms. So this is something that I would do in a lesson on the power law. So I've taught the multiplication law for index laws, I've taught the division law, and then when I get to my power law lesson, I teach them how to do the power law, and we do some practice of that, some simple ones. And then this comes in, which brings together all that other stuff I've taught them, as well as algebraic skills they've learned in the past. Okay, great activity, lovely stuff. And if you're teaching index laws in one lesson, you're not going to have time for this kind of depth. Okay, this is what I mean by teaching in depth. It's giving students these lovely tasks which make them think, which are not just straightforward procedural tasks. So I'll give you an idea of what I mean by rushing and what I kind of think the counter argument is to anyone that kind of tends to go through things too quickly. But I'd say that basically a lot of maths that we teach has a procedure. So you start by teaching this procedure, and then, or you don't necessarily have to start with it, but you might start with the procedure. And then the question is, once they've got the procedure, once they're basically replicating what you're modelling and they're having success with that, where do you go next? And some teachers will go for acceleration, and some will go for enrichment, and some will go for depth. So I'll just tell you what I mean. Acceleration would be related content from the next year's scheme of work. Okay, so that's where you say, well, I'm teaching this topic and they've got it really quickly. So instead of going into more depth, I'm going to go on to the stuff that actually they'd normally do in the next year. Okay, that's acceleration. Enrichment is where you might say, well, I've taught the procedure and actually now I'm going to really enrich their maths education by talking about some history of maths, or maybe some cross-curricular stuff, maybe a bit of exploration and project work, maybe some puzzles. I always do quite a lot of etymology, so I do some enrichment. So that's another thing you can do. As you know, if you have kind of lessons to fill and you want to make it worthwhile for students, that's certainly worthwhile stuff. My preference would always be, though, to go for depth. If I finish teaching procedure and they've understood it and they get it and they can replicate it, what else am I doing in my lessons so that I'm not rushing on? Well, I'm pulling out those misconceptions and addressing them. I'm increasing the level of complexity. I'm maybe showing multiple methods for things, exploring different representations. To make that level of challenge high, I'm getting students to think backwards. Maybe students generate their own examples, doing some problem solving. They must be doing some reasoning, otherwise it's all a big waste of time. And stuff like interweaving, like, am I bringing in those connections with those other topics? So when we talk about the different directions you can go once your students have mastered a procedure, you either accelerate onto next year's stuff, you enrich, or you go into greater depth, or you just go on to the next topic in the scheme of work, which I think is what a lot of people do. In the survey that I did recently, 39% of respondents actually said that they challenge students by teaching them more advanced topics. So we have 39% of the 700 maths teachers I surveyed accelerate. They don't go into greater depth to give challenge, they accelerate to give challenge. So if you've got a really smart class, you've got your top set year 8 or something, and they're really good at maths, then the question is, should you just accelerate them on, give them more advanced topics, or should you go into greater depth and find ways of stretching them within the current topic? And 39% of maths teachers are challenging by accelerating. And it's sort of, this is kind of this dilemma then. Should we add more content, or should we develop deeper, real understanding? And I'm not suggesting that if you're someone that accelerates, that you're not developing understanding or you're doing wrong by your students in any way. But the question is, are you definitely taking the opportunities to go into depth when the opportunities arise? And I'm going to show you loads of examples so you'll see what I mean by going into depth. Just one more example to show you the difference between accelerating and going into depth. Let's say you're teaching factorising, just factorising by taking out a common factor. Okay, so this at my school, we do this in year 8 and we have just done it literally this week. So say you're doing factorising and you've done a whole load of questions like the ones at the top of the screen there. So, you know, you feel confident they can do them, you've assessed them in some way, maybe mini whiteboards, you've gone and looked at their work or you've done some questioning, and yeah, they can all do this kind of factorising. To go into greater depth, perhaps you'll give them an exercise that has this exercise or some elements like this. So I gave this to my year 8s yesterday, and they did find it quite challenging. Look at question G, they're factorising out a pi. Like that to me was like a really good opportunity to talk about the idea of factorising out common terms, no matter what they are. In questions I and J, my students were doing that by simplifying and then factorising, which they did find quite challenging. And actually, when I worked out the answers to these questions, I didn't simplify and then factorise because I'm more expert in maths, and I found a way of doing I and J without having to simplify first. Look at question N on that sheet. That is index laws mashed in with factorising, and what a beautiful thing to give my students when they have done 2 topics this term, index laws and expressions. So this was really nice, that last one there, that it was really pulling out their knowledge of index laws. So this is a sort of activity that you can give students once they've mastered the stuff at the top to go into greater depth without moving on to the next topic, without moving on to next year's content, but to go into greater depth within the current topic. The alternative would be acceleration. So acceleration would be to say, why don't we do some factorising of quadratics? Or why don't we do some factorising of these are non-monic quadratics, which are even harder? And I'm not saying don't do that, but I'm saying, have you done the depth first? Or are you rushing on to stuff before you've done the depth? Because the depth needs to be there. If you think your class are ready for acceleration, great, but check first with the depth. You know, give them that really challenging stuff that's not accelerated before you make that decision. I want to talk briefly about the idea of teaching every student as if they're going to take A-level maths. And I know you might think some of your weaker students will never take A-level maths, but just having that high expectation of them and saying that, you know, if they get great teaching for their 5 years of primary school and all the time through primary school, their 5 years of secondary school, and you never know, they might go on and take A-level maths. So I talk to all my students, when I don't say if you take A-level maths, I say when you take A-level maths. And even the students who are kind of, you know, they're not great at maths and they're in a low set, and I still say to them, when you take A-level maths, you're going to need to know this. So this is something that's an interesting one with A-level, where there's a skill that a lot of teachers really kind of overlook that comes up in A-level. If you look at these 2 A-level maths questions, these are coordinate geometry questions. They're to do with equations of straight line graphs. Students need to know coordinates, which they learn at Key Stage 2 and Key Stage 3. They need to know linear graphs, which they learn at Key Stage 4 mainly, and Key Stage 3 as well. And then basically it's problem solving with those things. There's also some surds in there. So this is pretty much just an A-level question that just is asking for a slightly more complex question on Key Stage 3 and 4 content. Now, if you look at the last bit of those 2 questions, both of them ask about the area of a triangle. And students tend to find those last parts of these questions challenging. It's why it's the last part of the question, it's the hardest part of the question. And when I used to teach a lot of A-level, I'd often find that they became really sort of stuck at this bit of the question. And actually the key to that bit of the question normally was about knowing that you need 2 lengths that are perpendicular to each other to find the area of a triangle, unless you have an angle and you can use this sign to find the area. But if you don't have any angles, if you just have lengths, you do have to have 2 perpendicular lengths, okay? We know that, the students should know that, but they get to A-level and they wouldn't know that, okay? Now, I hope you can still see my slides because I just clicked on the wrong thing. Anyway, hopefully you can see a slide that says the area of the triangle journey. Right, so just think about the area of a triangle, okay? And think about how it starts in primary school. Finding the area of a triangle was something they do for the first time in year 6. And on the year 6 curriculum, it says calculate the area of parallelograms and triangles. Okay, so that's a year 6 content. When they get to Key Stage 3, the curriculum says derive and apply formulae to calculate and solve problems involving perimeter and area of triangles. Okay, so this is Key Stage 3 is pretty much the same as as year 6. Other than the year 6 thing just says calculate, and Key Stage 3 says derive and solve problems. But basically it's all area of triangle, okay? Now let's think about how this is taught at each of those stages. Primary teaching is incredible and wonderful, and there's lovely stuff going on at primary school. And I'm confident that at primary school, they're introducing the concept of area of a triangle. They're introducing it as probably half a rectangle, technically half a parallelogram. Okay, so students are seeing that if you split a parallelogram in half, you get a triangle, and therefore that's how we get that formula, that half base times height. So the half base times height thing is introduced at primary school, and students will do some practice and problem solving, and that's exactly what we want being done at primary school. They come to us and they should already know it. They will need a reminder, we know that, but yes, they have already seen that before. Okay, when they get to Key Stage 3 and we get them in Year 7, and on the scheme of work it might say area, and you think, right, I've got to revise area with them. What should we be doing at that point with area of a triangle? This is what I think we should be doing. We should be reinforcing the concept with examples and non-examples, focusing on that use of perpendicular. So a whole load of examples and non-examples, and a whole load of explanation as to why we have to have two perpendicular lengths, and we can't use a slant length, we can't use a length that's not perpendicular if we're doing half base times height. We should be interweaving. So if we've done some equation solving, then some equation solving should be coming up when we do area of a triangle. If we've done coordinates, then that can be coming up. Fractions, why not have fractions and decimals in the lengths when you're working out area of triangles? If we've done Pythagoras, which we don't tend to do till later, but that can come in for areas of triangles. Also, we should be using opportunities, we should be finding opportunities for students to reason and to problem solve. So, you know, stuff like complex compound shapes, contextual problems to do with area, you know, areas of a triangular field and stuff like that, and then working backwards. So here's the area, what are the lengths? And all of these things deepen knowledge. Knowledge they already had from primary school, but was very surface level knowledge because it's not introduced till Year 6, and that is the year they do their SATs, and they haven't got much time in Year 6. So that's definitely no criticism of primary teachers to say that it's not going to be the deepest knowledge at that stage because they haven't had the time. And they get to us and we say, right, you've seen this before, you understand the concept, so let's go into a greater level of depth on this particular thing. That's what I think should be happening. You may disagree, but that's what I think we should be doing. When I looked around at, you know, I know some teachers just download slides from the internet and teach their lessons through them. So I looked at Dr. Frost, I looked at some other ones, and I looked at how is area of a triangle being treated in these slides. And what I'm generally seeing is a quick reminder. I'm seeing two slides, one that reminds students of the formula, one that has a couple of practice questions, and that's it. So our students are coming into Year 7 having seen this topic at primary school, and they're getting a quick reminder, and then we're moving on. Now, I'm not saying we need to spend weeks on area of a triangle. I did one lesson on it, but I spent an hour on it in Year 7. When I taught Year 7 area of a triangle last year, I spent an hour on it doing those things I've listed there. I didn't just do a quick slide on it because it warrants some time because of the opportunities for reasoning. If they already know how to do something, that's when you have the opportunity to get them solving problems and doing some reasoning with it. Okay, I don't agree with like pushing them into reasoning before they have the knowledge. Here they have the knowledge, so we're ready for the reasoning. And here, just to give you, I don't want to talk about area of a triangle all day, but here are some of the examples of things that I have used in the past on area of a triangle. So last year, when I taught this to Year 7, I didn't use all of these activities in the one lesson. I did an area of a triangle because that would be me trying to cram stuff in. You know, just doing loads of activities does not make good teaching. But here are some of the things we can do. So we've got that top left one, for example. That's a lovely question on area of a triangle. Really nice question. There's loads of stuff from MathsPad. If your school does not subscribe to MathsPad, go and tell your head of maths now. Get a MathsPad subscription. At Harris Sutton, we all use MathsPad a lot. The resources are brilliant, include Key Stage 3 and Key Stage 4, absolutely fantastic resources. They're one of my key sources of tasks for my lessons. So absolutely brilliant, but not a free website, although some stuff on there is free. So most of that stuff there is from MathsPad, not all of it, but you know, there's some really nice stuff there, like find the area of the kites and the rhombuses, and you do that by cutting them into triangles. And you know, we can't say, you know, if you want your students to practice area of a triangle without being patronised and just doing primary stuff, then give them some kites and rhombuses, and they can split those kites and rhombuses in half and find and practice and develop fluency in area of a triangle that way. But all of this is going into greater depth. We shouldn't be rushing things. Some of you will be saying, oh, they've done it before. Don't give them stuff they did at primary school. And you hear a lot of people say that. Don't give them stuff in Year 7 they've done at primary school. I massively disagree with that. We don't think we should have Year 7 should not be a repeat of Year 6. That would be stupid. We don't want to repeat all the stuff they've done before. But we should be going through the stuff they've done at primary school and going into greater depth. We've done it before anyway, just to give some context to that. In 2019, 79% of students, that's the last time they did SATs in Year 6, 79% of students basically passed. That means they got expected standard, okay? But to get expected standard, you know, they only had to get 53% in Year 6 to get expected standard. So they could get half of their maths SATs wrong, and they're still coming through pass with a SAT score of 100 plus, so expected standard. They could get half of it wrong. And this isn't a criticism again of primary, because it's the same at GCSE, isn't it? You can pass your GCSE maths and get most of the paper wrong, and you can still pass your GCSE maths. So saying that someone's passed their previous step in the process does not mean they know the content. Okay, so we shouldn't just assume if it's on the primary curriculum, it's known well, because we know it's not. We know that they can get half the paper wrong, still come through on expected standard. And actually what that means is we can take the stuff they've been taught before and go into greater depth on it, but not skip over it. Also, regardless of what they've done before, you can always go into greater depth. You can have a top set year 10 who have done any topic before at Key Stage 3, and when you get to them in year 10, you think, oh, I don't want to do that again. They're all going to be really good at that. Fine, don't do it again, just go into greater depth on it. Okay, there's always an opportunity to do that. And just one more thing on area of a triangle. If you have got this amazing high-flying top set class who are incredible, and you want to give them some challenge on areas of a triangle, there is no shortage of challenge. This is a Don Stewart question, really challenging stuff. The one at the bottom there is a puzzle from Ed Southall. I struggle with things like that. Like, I really have to think about solving problems like that. And if you're saying that your top set year 7 don't need to do anything on area of a triangle, why don't you give them that and see how they get on with it? Okay, and give them some thinking to do rather than just rush on to the next thing. Okay, and then area mazes are beautiful. They're so much fun to do, area mazes. So even with the most high achieving class, we can go into depth. Just want to talk briefly about why we rush in maths, because it's not always our fault, and it's definitely, I'm not blaming teachers for this. We rush partly because our national curriculum is overcrowded. And I've done some analysis. Basically, I went through the entire Key Stage 3 and 4 national curriculum, and I wrote down how many hours I would like to spend on each topic. And I was basically, I'm 20%, I'd have to cut 20% of the national curriculum to fit everything in at the pace I want to go at. So it is overcrowded. We do have a very, very busy national curriculum in this country, unfortunately. Sometimes it might be suboptimal scheme of work design. You know, there are some schemes of work where you literally change topic every single week. So where are you going to get time to go into depth if you change topic every single week? Sometimes it's a lack of teacher expertise, and that's, again, not a criticism of the teacher, but sometimes the teacher has never observed anyone who's teaching in depth. They haven't had the opportunity to do that. Certainly at the first school I worked at a grammar school when I first became a teacher, and everyone taught very, very quickly, and all the students did really well at GCSE. They all got A stars, and then they got to A level and they had a really shallow level of understanding because everything had been rushed through, and because the teachers there knew how to get good GCSE results, but they didn't know how to teach in depth. So actually, there is sometimes a lack of expertise. But the other thing, actually, and I think this is something a lot of you might be thinking, is that sometimes we don't go into depth because of a lack of suitable resources for depth and challenge. And sometimes we're trying to go into depth, we're trying not to rush a top set or any set, in fact. So we're trying not to rush any class, no matter what their level. We're trying not to rush them through it, but we're saying, I just can't find appropriate resources to teach them in depth and to give them challenge without acceleration. So sometimes people say the lack of resources is the issue. And actually, thinking about it now, when I've got a set 4 out of 5 year 9, and when I'm teaching them, I think this term already, I've rushed a little bit, because I think, oh, they're finding this really hard, so I'm just going to get it out of the way. You know, they're finding this tricky, so I'm just going to finish this topic and move on to the next one. And that's not okay. I shouldn't be doing that. I should be seeking out advice, seeking out the expertise of other teachers who have taught similar classes and said, look, how can I get them to understand this with a level of depth? Because I shouldn't just shortchange them because I think, well, they find maths hard anyway, so I'll just rush. Everyone deserves depth in their teaching. Just on the resource thing, if you're thinking that you just don't have the resources, a few bits of inspiration. I'm going to share these slides afterwards, so you don't have to write all this down. You will see them. But MathsPad, like I mentioned, they've got these new curriculum booklets. Just have a look at that one. The Year 7 chapter on indices. They give it 13 to 17 hours on indices. So this is an example of a curriculum that really goes into depth and then doesn't repeat stuff all the time, which is how they fit it all in. And they've only done Year 7 and they've started to do Year 8, but those curriculum booklets are really helpful. If you're planning a topic and you think, I don't know where I can go with this topic to challenge my students, have a look in the MathsPad booklets if you have access. Some of them are free, most are for subscribers. I find Hegarty Maths, I know many Harris schools use Hegarty. I find Hegarty Maths quite helpful for looking at the structure of his lessons. So for example, if I'm looking inside, or we're just doing, with year 10, we're doing advanced trig. And I was really interested to see that he started with 3 lessons on half A, B sine C, and I normally do that at the end. So actually looking at how he breaks topics down can be quite interesting, like how has Colin Hegarty decided to atomize or break down a topic, and sometimes it gives you a bit of inspiration for your own planning. White Rose, if you have access to White Rose resources, is great for depth of knowledge. There's a website, foster77.co.uk. That's Colin Foster. He is a PGCE tutor at Loughborough, and he's got a website full of really great ideas for challenge or for reasoning within topics. Paul Rowlandson is a maths blogger who writes fantastic posts about individual topics. His recent post about teaching Pythagoras and trigonometry, about teaching probability trees, they've been so helpful in my planning, and I've taken lots of ideas from those posts. Same thing for Dan Draper's blog. He basically writes about how he has gone into depth when he has taught, and you can get ideas from those things. Also, I have done a series of topic in-depth CPD sessions. Some of them are just available in PowerPoints, but some are recorded, and they were recorded by Tez, and they're available on YouTube. And it's basically me talking through how to teach a topic in depth. Now, I've not done that for every single topic on the curriculum because I don't have that much time, but it gives you an idea when you watch this CPD of how you can go into greater depth without accelerating. I mentioned this earlier, and I'm not here to, I don't make any money from my blog, I'm not here to sell it, but I do have a website, resourceaholic.com, and sometimes when people are saying they can't find challenging topics for certain subjects, challenging resources for certain topics, then I'll say, have you looked at my blog? Because if you go to the resource library, and for example, if you're searching for challenge on indices, if you click on indices there, you've got quite a lot to choose from. And I have definitely got a lot of challenge in there, because I used to teach at a grammar school, and that's when I first built this blog, and most of the stuff I was putting on there was for the high achievers. But now, over the years, where I've taught a wider range of students, I've put on all sorts of resources. But there's certainly stuff for depth on my blog. I'm not saying it answers all the questions and it provides the resources for everything, but there's certainly depth there. You might be interested in how long other teachers spend on things. So I did this in my survey that I did in the summer term. I asked the question, and what I was trying to get and I know that it's a bit hard to ask this, but I wanted to know how long the scheme of work allocates to each of these topics. So in everyone's school, how long are they given to teach these topics? Because most schools do have some recommended timings in the scheme of work. We don't necessarily have to stick with them exactly, but most schemes of work give an idea, and they're normally in kind of 1 week chunks. So this is really interesting. So you can see that most people get 4 hours or less to do angle basics. Now that, to me, in year 7, I spend 3 weeks on angle basics. I can't believe it's 4 hours or less. Most people are getting 4 hours or less to do angles and parallel lines. Again, that's something that I spend 3 weeks on. So I was quite surprised by some of these low allocations. Things like, Pythagoras actually is one where people are given a bit more time, between 4 and 8 hours. Same with trigonometry. But there are some things there where people are getting what I thought was not very much time. Not in every case, some of this is as I expect it to be, but yeah, not as much time as I was expecting. Let's just have a look at one quick example. So constructions. I hate teaching constructions, I will be honest about that. It is my least favourite thing to teach. I did a better job of it last year than I've ever done before, because I really thought about it and I said, I am not going to just rush this one. I'm going to give it some time, some planning time. I'm going to give it some thinking before I teach it. And that made my teaching a lot better by just giving it a bit of space in my brain. But this is really interesting. How much time does your scheme of work allocate or advise for teaching constructions? And out of my 700 respondents, around half said they get basically under a week, so 4 hours or less. They get 4 hours or less to teach constructions. Now I thought about that and I thought, is that enough time to teach constructions? The whole of Key Stage 3 constructions presumably is being taught at once. It's not something we're spreading out. If you look at the curriculum, the question is it enough time? So this is what's on the curriculum. Constructing triangles, and remember there are 3 different scenarios. You can be given all the sides, given angles and sides. Constructing perpendicular bisectors, constructing a perpendicular from and to a given line, constructing an angle bisector, and constructing an angle of 60 degrees. They're the things that are specified. They are specifically mentioned on the national curriculum. Now I looked at that and I thought, I suppose you could do that in 4 lessons or less, or 4 hours or less. I suppose you could do, maybe. But then I thought about when I taught it, and I went into a bit more depth than that. So for example, I did construct a hexagon, I did construct a rhombus, by sticking 2 triangles together. I did 45 and 30 degree angles by bisecting the 90s and the 60s, which is really, I think everyone should do that. I mean, you're basically bringing together different skills there, which is really important. And of course, then I did some loci problems. Now, I suppose some people might not be including loci when they answered this question. But another thing I did was my very first lesson was basic compass skills, and we did some lovely mandalas, some beautiful drawing of circles to practice. So my students became really good at understanding the definition of a circle, but also just those lovely compass skills and that dexterity they need in their hands that we know that a lot of students struggle with at first. So even if you don't go into a huge amount of depth, I still think 4 hours isn't much. If you're going to do the first lesson on compass skills, that's really not leaving you much time to do triangles, perpendiculars, angles. I think it seems a bit rushed. So I guess it depends, I guess if you're teaching that in under 4 hours, I think you really are kind of skimming the surface. It's like procedure, 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 move on. But if you're taking a little bit more time on it, and I didn't spend ages, I hate teaching this. I spent about a week and a half on this. But if you spend a little bit more time, at least your students are getting a slightly less kind of shallow experience of the curriculum. I want to talk to you about atomization. Oh, you know what? I didn't say at the beginning, but just to reassure you, in case you're sitting there thinking, oh, Jo's been talking for ages, I am going to talk probably for about another half an hour, okay? Then I'm going to set you a little task to do, so you have a bit of time on your own where you can go off and just do the task for a little while, and then you're going to come back at the end and we're just going to have a look at a bit of a summary, okay? So please don't think I'm going to talk at you for 2 hours. I'm not going to do that. But I'm going to talk for, I think, about another half hour. Okay, and I want to talk to you now about, I'm going to show you some examples of my lessons, of my sequence plans, and I want to talk to you about atomization. I won't say that atomization is some official teaching term. It was coined fairly recently, but it is a useful way of describing the breaking down of a topic into subtasks. And actually, I don't even think task is the right word there. It's breaking down a topic into its sub-elements, and then that helps you work out your sequence plan. So I could look at a topic and say, what are all the little bits of this topic that fit together to make the topic? And then that helps me write my plan, my sequence plan. Okay, so this is my approach. So let's say I'm teaching a topic. In fact, what am I teaching next week? I don't even know. Let me think. So next week, after half term, I will be teaching some fresh topics, some topics that I'm finishing off some topics next week. I'm finishing off expressions with year 8. I'm finishing off angles and polygons with year 9, and I'm finishing off trigonometry with year 10. And then after half term, I'm starting 3 fresh topics. Okay, so with year 10, I'll be doing quadratics, and that's a great example because that's huge. So this is how my approach always works. At the start of a unit, I sit down and think, and I know that as teachers, we do not get much time to think, but this is really important, and it can just be 5-10 minutes of thinking. And I think about the topic and I atomize it. I'm not like making vast amounts of notes or anything. In my head, I atomize it into the individual skills and concepts. So for example, for quadratics, I will think of all the little bits that come together. So the solving by factorizing, then solving by factorizing, but understanding with factorizing that it's all about the zero product rule. Quadratic formula, completing the square. So I will sit and I will not almost brainstorm those things. I mean, I'm not like a mind map sort of person, but you could do a mind map, I guess. Then I map out a proposed sequence of lessons, and there I'm being mindful of my time constraints. I can't plan 4 weeks on Pythagoras if my scheme of work says I really need to get it done in 2 weeks. Because if I do decide to always be really maverick and always plan double the time, then my poor students are not going to actually finish the scheme of work by their end of year assessment, and I don't want to let them down like that. I want them going into their end of year assessment with the same, having been taught the same topics as the rest of the year. So even though I'm not saying you have to stick rigidly to the timings on the scheme of work, you do have to be mindful of them and just make sure that your students are, not being left behind. So I map out my sequence of lessons, and then I share it with students, and I actually share it every lesson, and I will show you in a minute what I mean by that. I share the sequence right at the beginning of the unit. This is what we're doing in the next 2 or 3 weeks, and then each lesson I'll show them where we are in that progression. And then, really important, I adjust as I go, because maths teachers, more so than any other subject, need to be responsive. And it would be absolutely crazy for me to say, this is how I'm going to teach this topic for 3 weeks. Here's my order of lessons, and think that I cannot adjust that. Because actually, if in one lesson they didn't quite get what I was saying, I didn't explain it very well, or perhaps it was just more complicated than I expected it to be, I'm going to need some more time on that. And I can't say, oh no, I can't, because I've got a sequence planned out. I will have to adjust and respond as I go, and that's fine. So then I just, each time I edit my sequence plan if I need to, okay? And we should of course be doing that, because we don't plan whole sequences in advance and stick rigidly to them, because we have to respond. Here's an example then. So this was my year 8 set 2 out of 4. They are pretty smart, so I had to put some challenge in there for them. We were doing index laws. I spent 3 weeks on index laws, and this was the plan at the beginning, and each lesson I showed this to students and showed them where we were. I was like, right, we are at this point today, we've already done this stuff, this is what's coming, you know, and it only takes a minute in each lesson to sort of show them the progression. I think they like to know what's going on. So you can see that I started with a recap of index notation, and then I did the 3 index laws separately. I did a lesson where I consolidated them, and then I went on to slightly more advanced stuff. So I tried to challenge them with some stuff on. We did some calculator work. I made sure they know how to do roots and indices on their calculator. People so often skip calculator work. It needs like proper teaching time using calculators. 2/3 of their GCSE is calculators, but a lot of students are barely using them at Key Stage 3. Other things you can see popping up in my scheme of work are the self-assessments. So you can see that I have those little purple icons. Basically, at the Harris Academy Sutton, we have a new thing this year where at the end of every week, if we're not giving them a proper test, we give them a kind of little 5-minute self-assessment. They do it in test conditions, and it's really helpful for them to see how they're getting on. And at the end of the unit, we always do a learning snapshot, which is basically a test, and then they will get proper feedback on that test. Here's another example. This was my year 10 on surds and indices. This is set 2 out of 8. So again, I do have quite a high set here. I have my year 9s are my challenging class. I don't want you all to think that I just teach these kind of easy classes. Although we are very lucky, our students are really, really hard working at this school and just a delight to teach, absolutely delightful. Oh, by the way, we're going to be recruiting maths teachers this year, and if anyone wants to come join us, Harris Sutton's a great place to work. Right, so we have this year 10 surds and indices thing. I planned it at the beginning. The greyed out stuff is retrieval. So greyed out stuff they had done a bit of in year 8, okay, but they definitely needed to go through it again. Then all the stuff that is not greyed out was new content, and you can see I have atomized these topics. Look at the surd stuff. I atomized it quite a lot. I did simplifying separately to adding, separately to multiplying, separately to expanding brackets, and then I did rationalizing. I needed more time. One more lesson would have really helped me out here. I had to rush the rationalizing. I think I needed 2 lessons on rationalizing. But anyway, you get the idea. This is what I do at the beginning of a sequence. I make this for myself before I start teaching the whole sequence. I plan it out, and then I show the students, and I change it if I need to. Right, last bit of my talking before I ask you to do a task is to just sort of talk to you about what depth looks like. And I'm going to go show you 3 topics, angles, sequences, and Pythagoras theorem. I'm going to show you 3 topics where I give you an idea of how to teach it in depth. But it's only my ideas, and you know, I'm not the expert on teaching these, but I've thought about it quite a lot, and I've come up with sequence plans that I think worked quite well last year. So first of all, angles. And what does depth look like? Now, this is year 7 angles. I taught angles to year 7 last year. We do not do parallel lines in year 7, which to me is really important. I think they should see basic angles in year 7, and they should see parallel lines in year 8. But I did 3 weeks. I don't think it was enough. I had a middle set year 7, quite a mixed ability middle set. I don't think it was enough 3 weeks. I did have to rush a little bit. So my 3 weeks started with some drawing, labelling and measuring. That's where I didn't have enough time. Some of them were really bad at drawing and needed a bit more help on that. We did some classifying. We then went on to angles on a straight line and vertically opposite. I did a whole lesson just on those things. Then we did some angles of algebra, and that angles of algebra was angles on a straight line solving equations. Okay. Then I did angles and triangles. Then I did some isosceles stuff, a whole lesson on isosceles stuff, because there's tons of depth you can go into there and some great resources. Then I came back to angles of algebra. So I did my equation solving again, but this time with angles and triangles. So because I know that that's something that students often struggle with, is solving equations when you have an angle problem. So I did it twice. Then I did a whole load of stuff on quadrilaterals, starting with the angles, then 2 lessons on quadrilateral properties. I probably could have done more actually. Then we finished off with some mixed angle problems. I gave them a little assessment, and then we went through it and improved. I think it wasn't quite enough, because I did need more time on drawing and measuring. I didn't really spend enough time talking about parallel and perpendicular and going into a lot of detail on the notation for those things. I think I could have done, on the quadrilaterals, I could have done a whole lesson looking at quadrilaterals drawn on coordinate grids, because that would have been a great way to do some retrieval on coordinates, and I didn't do that because I didn't have enough time. And there's actually some things that I could have done on isosceles triangles and circles, and I'll show you that in a minute. All of that is within, none of that is acceleration, all of that is within this topic, so I wasn't accelerating, it was all in depth. 4 weeks probably would have been better. I know that it's not practical for us to have 4 weeks on the scheme of work, and that is fine. So I did it in 3. So yeah, sometimes we, it was a little bit rushed, but it's probably a lot more depth than some people go into on angles in year 7. I'll show you a few of the lovely resources I used. Oh, I really like this one. This was from Foster 77, which is Colin Foster's website. It's just a little grid. They stuck it in their book, and they had to draw in each box an example of a triangle that fits that description. Okay, so for example, can they draw an acute angle scaling triangle? You'll notice that some boxes can't be completed. For example, obtuse angled equilateral, right angled equilateral. So those boxes got left blank, and that gave the students something that they noticed, something that they thought about. They thought, can I put something in here? And it was just great to hear them reasoning about it. Interestingly, the one I was surprised by the one they struggled with. Quite a lot of students couldn't figure out what to put in that bottom left box there, scalene right angled. And I couldn't really see what they were struggling with, other than the fact that when they tried to draw a picture of a right angled triangle, they kept drawing like a sort of classic isosceles, where it's like a right angle and a 45 and a 45. They didn't know how to make one of the legs longer on the triangle, and they just couldn't seem to figure out, they couldn't get their head around how to draw it. In the end, I was having to draw examples on the board, because even when I said, just make one of the sides longer than the other, and they just couldn't figure out how to do that. So that was interesting. But yeah, it was a great task, and that's something that's just, reasoning and depth and not going outside the topic of angles. A few more things that I did with that year 7 class. I mentioned isosceles. John Stewart has tons of stuff on isosceles triangles. I love these questions. I absolutely love that one, the sort of top left ones on the second sheet, where there's no angles marked, but you can still work out the numbers. I love that. But I could have, if I had top set, then he has questions like this that involve proofs. And that's brilliant. Like, do that. If you're saying, I can't challenge my top set year 7 on angles and triangles, then why aren't you giving them the geometric proofs on Don Stewart's site to do with isosceles triangles? Because that would challenge them, definitely. I don't care how amazing they are at maths, I'm pretty sure that would challenge them. So there's definitely opportunity to challenge everyone on angles and triangles. Isosceles triangles are great. This task worked really well, and in fact now I use this one with other year groups as a good recap of year 7 angles. I gave this to my year 9s. I've got this sort of set 4 out of 5 year 9. I gave them this week because they were recapping angles ahead of doing angles and polygons. They found this quite tricky. They started off saying it was really easy, and then they did find it quite tricky because you have to really think about where the right angles are. You've got some isosceles triangles. It's a great task though. Works well with year 7 and works well for recap in year 8 and year 9. Algebra, so you've seen these before, I won't go into detail, but plenty of resources exist on algebra in angles. Loads of resources on MathsPad for quadrilaterals, identifying the quadrilaterals, talking about their properties. So it's something that a lot of teachers skip over because it's like not the most exciting thing to teach, quadrilateral properties, but there are some great resources on MathsPad. And I mentioned isosceles triangles and circles. This is great because this is a circle theorems thing, but actually you can do it just with year 7 angles knowledge, because every one of these triangles are isosceles. So actually, it's really, you could do this easily in year 7. It's a beautiful exercise. And all they have to understand is that the radius equals the radius. And they know that because they actually do the radius. I think they learn the radius, the word radius at primary school. So even though they haven't done anything to do with circles at secondary, it doesn't matter. You can very quickly establish that 2 lengths there are equal. And then it's just an isosceles triangles problem. And doing this now is building those foundations for circle theorems. Finally, I said that a lot of my students needed more practice on drawing and measuring, but actually maybe it was about a third of the class were a bit rubbish at it. So what I should have done there, and I didn't do this because I ran out of time, I should have said, right, I need another lesson on drawing and measuring. And the students who were already able to do it can do a task like this. This is from MathsPad. And in this task, they are literally having to construct a rocket ship by doing lots of drawing and measuring. And then so they're doing that and they're practicing and they're engaged and they're getting on with it. And while they're doing that, I'm going to those individual students or groups of students who can't do a basic bit of drawing and measuring, and I'm helping them. So the rest of the class is engaged in some fluency development and some practice while I'm helping those who just couldn't figure out how to do the sort of basic measuring. Right, so that was angles. I'm going to just show you 2 more. So sequences, I want to talk you through what I think depth looks like in sequences. Now, we taught sequences to year 8 last year. I did it in about 2.5 weeks, which was about right on the scheme of work. We have 2 or 3 weeks to get through sequences on our scheme of work in year 8. And this is how I structured it, although there's loads of different orders you could do this in. I started with special sequences, like I talked about the square numbers and the cube numbers, but mainly focused on Fibonacci in the first lesson. So I did a good half hour talking about the wonders of Fibonacci. Then I did some stuff on missing terms in arithmetic sequences, which students find harder than you expect. You know, if you have a sequence where you've given the first number, then there's 2 gaps and then they get the next one. Like, it was interesting that they couldn't reason on how to do that. And I talk about how it's like, you start on this number and you jump, jump, jump to get to that number. You've done 3 jumps. So you're going to take the difference and divide it by 3. But I was surprised they couldn't just spot that, to be honest. Then I did some nth term lessons. I did a finding nth term and a using nth term lesson on arithmetic sequences. Then I did some stuff on recognizing and continuing geometric and quadratic. We're not doing nth term. If I did nth term of quadratic, that's acceleration, because that is a GCSE topic. Nth term of quadratic sequences is for year 10s. I did not do that, but we did do some looking at them and spotting how do you know it's a quadratic sequence. We did some work on generating sequences. I'll show you the resource in a minute. It's really nice. And we did 2 whole lessons on problem solving with sequences. Then I gave them a little assessment, and then we did some improvement at the end. So let me show you some examples. Oh, first of all, I felt like I needed more time on Fibonacci. I only did half a lesson on it. I think I could have done a lot more than that. Have a look at this. This is from my assessment at the end. I had a middle set year 8, and at the end of this topic, they did this assessment. This is one of the questions. So this one was a nice one. Write down the next term in this arithmetic sequence. So they have to realise that if it's an arithmetic or linear sequence, it goes up by the same amount each time, or you add or subtract a common difference. And that means they just had to work out the difference between those 2 terms and then add it on. Whereas the next one was Fibonacci style, same terms in the sequence, but now Fibonacci. So now they know they have to add those 2 together. So that was testing their understanding of different sequence types, but also interweaving their knowledge of collecting like terms. In this last question here, this is the one a lot of them couldn't figure out. This was a real reasoning, problem-solving question that only a couple of students got full marks on. And you're given a sequence, you're told the difference between each number is 9, and you're told the sum of all the terms. So it's going to have to involve some negatives. I would solve that with algebra, and this was a great opportunity to talk to my class about how algebra comes in handy. Okay, you don't have to use algebra to solve it, but it does come in handy. Some of the resources I used with that class included this beauty from MathsPad. I love MathsPad. Anything that involves filling in gaps like this in a grid means students are thinking backwards, which is reasoning. So it's not just a load of procedural practice of the nth term. It's like procedural practice of the nth term, developing fluency and thinking backwards. So it's just great for all sorts of reasons. Anything like that, a grid with fill in the gaps, is really, really good stuff to go into depth with students. I gave them these cross sequences, which they really enjoyed. These are basically sequences with missing terms. All of these were arithmetic sequences. So you can see the first one's nice and easy, 3, 5, 7, 9, but some of them are a bit harder because of where the gaps lie. They really enjoyed those. Then I used things like this, again from MathsPad. So that is a cross word, a cross number, where they're actually, in some cases, using an nth term. So in that first one, B across, they're saying, right, if I substitute 1, what do I get? And 2, like how's the sequence going up? Filling in the sequence, but some of them they're having to work out the nth term. So it's a wonderful combination between using and working out nth terms. And this was kind of right at the end, we did this as one of our summary consolidation exercises, and it's basically filling in the cross number where you're told the type of sequence. And they did find one clue on here, had lots of them stumped, but they really got into this. And I'm not saying that my students will not need a reminder of this stuff before GCSE. They will come back to it in year 10 or 11. But we really went into depth on sequences, and it was just so much better than here's the nth term, let's move on. And this was a nice task that we used as well. This is a generation of examples from students. So where I say find an nth term such that, for example, the sequence contains only odd numbers. So they can write out the sequence, but then I need them to find the nth term, so they're practicing that. And then once they've done some of these, you can say, any sequence that contains only odd numbers, what would that have to look like? So you've all got different answers here, but what would it have to go up by every time? And what would it have to start with? So you have to start with an odd number, then always add on an even number, and then you've only got odd numbers in your sequence. So it was really good discussions from that one. If you haven't seen Mass Vens, that's just perfect for reasoning. If you've got a class who are really strong and you're always thinking, I don't know what to give them, have a look at mathsvens.com. I mean, there's great stuff on there. You can get really complex ones, you can get quite simple ones as well, where they're having to think of examples to go in each region. Really, really good. This one's on sequences, but they have lots of topics. Finally, I said that I felt like I didn't have enough time on Fibonacci. I did do a little bit of stuff like this, but I definitely could have done more. Fibonacci comes up quite a lot of GCSE. And I really like these Fibonacci style sequences, particularly where we're using roots and we're using fractions and we're using decimals and algebra. Like, that is a huge amount of interleaving that can go into questions on Fibonacci. Right, last thing from me before I ask you to do a little task. So we are going to look at how I taught Pythagoras. Again, I'm not saying this is how you should teach Pythagoras, but I want to show you how I went into depth on it. Bear in mind, my teaching has changed over the last decade and has become very much a kind of rush through things kind of style into a go into depth and make a point of it style. So by me showing you how I structured things, it hopefully will give you some ideas, and you might already do this better than me. So Pythagoras, right, first of all, let's just have a look. In my survey, 42% of teachers spent 4 hours or less on Pythagoras, 48% spent between 4 and 8 hours, and 10% spent more than 8 hours. Now I'm in that 10%. When I did Pythagoras last year with year 8, I was definitely in that 10%. I definitely did more than 8 hours. This is how my my 3 weeks went. This was with a middle set year 8 again. I started with a, actually I didn't, but on reflection, I should have. When I started teaching it, I realised they were struggling with some of the questions that asked them to round in a certain way, particularly if it said round to 3 significant figures or something like that. So actually next time I'm going to start with a rounding recap, because they hadn't done rounding since year 7, and it was the first time they'd actually been asked to do some rounding in some maths, the first time where the question required some rounding. So next time I'll do a rounding recap. Then I did a bit of work on roots and squares, including calculator use, making sure they know how to use those buttons. We did a bit of work on labelling triangles, what's a hypotenuse, and then this is where a bit of enrichment came in from me. It's not all depth, some of it's enrichment. I spent about half a lesson talking about the wonders of Pythagoras, the mathematician. Okay, that's not essential, it's just a nice thing to do, but it's definitely not something that's for everyone. Then I did a whole load of work on using Pythagoras, so a number of lessons on that, including multi-step problems, worded problems, converse, so, you know, when you're asked whether a triangle is right-angled, distance between 2 points on a graph, you know, they already know coordinates, so, and that's just Pythagoras. And then I felt I didn't have to do 3D Pythagoras. I could have cut these 2 lessons, because actually this is something that comes up later, comes up in year 10. So I didn't have to do those 2. I could have cut it down, 3D Pythagoras lessons. But that was my 3 weeks on Pythagoras. For further depth, if I'd had maybe a top set, I might have done some more stuff with thirds there. I might have done a investigation of triples, Pythagorean triples. That's really interesting. I don't tend to do investigations, but I could have done that. And if I had a top set, then actually an investigation as triples is really quite challenging and interesting. I didn't do any proofs of Pythagoras. I'm not a fan of sort of starting a topic with a really complex proof. Some people would disagree and would always do a proof. And actually, if I wanted to enrich, I could have talked to them about Fermat's last theorem, and I could talk for an hour about that. Like, I could do a lecture on that. Like, that is like the best thing. I didn't do that. So I definitely could have done more, but I didn't. I still spent quite a long time on it. Now, some of the things I used, I made this resource, it's nothing special, but basically in the very first lesson where I wanted them to practice roots and roots and powers, I gave this exercise to just draw out some misconceptions. Do they know how to square a decimal? And this was all without a calculator. Do they know how to use a square root? All that sort of thing. So that was the first. I'm just going to answer the question in the chat. So Emily's asking, do I have time to cover all the topics? It's a good question, because I know that, you know, I do stick to the scheme of work. I mean, I'm lucky that our scheme of work, very well designed by our head of maths, mostly gives me the time I need. I do have to rush some things sometimes. I'm not saying that every single topic I teach, I go into great depth, because some things I do have to rush, and everyone does, I think. Unfortunately, that's the nature of our national curriculum. So what I do is I kind of pick, so maybe key topics where I go into depth, and then some topics have to be sacrificed and they're not quite as in depth. I generally, I don't run out of time. I do fit everything in. I don't tend to do like a whole week of revision before the end year and mid-year assessments. I will do one revision lesson because I'd rather spend time teaching in depth than revising with my classes. We use Hegarty for homework, so they're practicing at home. But basically, I would never leave my classes with an unfinished curriculum. I will always finish the curriculum, and that does mean that some things can't go into a great deal of depth. But I do feel like we should all be picking at least one topic per half term that we're going to really go into depth on. I think that would be a sensible place to start. But Emily, you're absolutely right. I know there's no way I can get time to spend kind of like 4 weeks on everything. In an ideal world, I would, but I am an actual maths teacher, so I can see the practical side of it. And no, can't do that, unfortunately. But yeah, I do think that if you can sort of look at the whole term that's coming up and plan out these chunks of time, then try and give some of the really core fundamental things a decent amount of time. This is Pythagoras as well, really lovely stuff. Look at this one where they're matching it up to the exact value, and there's one there where they have to work backwards, which is lovely. There's one that ends up blank at the end, and then they match it up to the one with the question marks, and they have to come up with some values that works. Really, really nice. This is compound shapes, where you're having to use exact values in your calculation. I tell them, this is a mathematician's skill. Okay, a mathematician's skill is where you work out one answer, and you, instead of rounding it, you write that down in root form, and then you use your ANS button on your calculator to do the next bit. And I really stress that. And in the exam at the end of the year, a few of that class did this so well. I was so proud, and I fed back to them. I'm so impressed that some of you have already developed what I consider to be like an A-level mathematician skill of the use of exact values during calculations. Really, really good stuff. That's a lovely bit of depth on Pythagoras. Why is this shape not a regular octagon? Like, what a nice question to ask as like a warm-up with a top set doing Pythagoras. Quick warm-up question. Why is it not a regular octagon? Use mathematical language to explain your answer. Like, what a nice question. And then there's loads of stuff you can do. Like, this is from, I did not do this. This is great. From ponderingplanning.wordpress.com, Paul Rowlandson's blog. Use the information to determine if this is acute, obtuse, or right-angled triangle. Now, that's a great question. I know the 6, 8, 10 is right angle because it's a Pythagorean triple, but I've never even thought before about what the other information tells me. Like, that is depth. That is top set depth going on there. Don't rush on to the next thing. Do stuff like this with your top set. And then questions like this, lovely question, where it's isosceles, so they're going to have to do x squared plus x squared equals 10 squared, and that gives them 2x squared. They have to solve the equation, something that a lot of students struggle with. And that's actually the same question, but put into the context of a circle. Exactly the same question though, because the radius is both x. Really lovely stuff there. I won't go through all this in a huge amount of detail because I want to let you have a little break now, but just, you know, loads of stuff you can do on Pythagoras. This is a Pythagoras question. You can't say you finished Pythagoras with a top set and say that and not have done stuff like this. If you've done it really quickly, come back, give them this, get them thinking, get them reasoning. Otherwise, you're just not giving them the opportunity to be able to do some reasoning. You have to give students the opportunity to think for themselves. I did some of this. So I did the finding distance between 2 points with Pythagoras, but this, like, find the perimeter, for example, that takes a little while. And then the distance between 2 points is this, find what the points are, so thinking backwards. Really nice level of challenge. This is Pythagorean triples, really nice questions there. And then finally, you can interleave equation solving with, interweave equation solving with, sorry, I had someone at the door there, I don't know if you saw them, send them away. Equation solving with Pythagoras, and I have a question here on circumference of a circle with Pythagoras. So lovely interweaving of other topics. 42% of teachers spend less than 4 hours. And look at all that amazing stuff I just showed you. Like all this great stuff you can do on Pythagoras, and people are just getting it finished in less than 4 hours and moving on. Like, it's just not enough time. And, I know, sometimes it's literally down to scheme of work design not giving you enough time. And sometimes it's down to teachers not knowing how to go into depth. There's tons we can do here. 4 hours shocked me. 42% of teachers under 4 hours on Pythagoras. Oh, not enough. Right, so I'm going to stop speaking now. What we're going to do is that I'm going to explain to you the task I want you to do, and then we are going to get back together at 12:15. So that will give me 15 minutes at the end just to finish off the session. What I'd like you to do is go off and map out a sequence plan for either one of these topics, or for something you're teaching next week or after half term. I want you to think about the prerequisite skills that are needed, and that should probably come up in your sequence plan. So what do you need to start with, because they can't do the topic unless they can do this bit. Atomization, break that topic down into subsections. Challenge and depth. How are you going to challenge your students, whatever class you have, whether they're a top set or a bottom set? How will you give them the right level of challenge, and how you go into the right level of depth for the class in front of you? So you can either do it, I'm going to show you my versions for these. Year 7 area and perimeter, Year 8 angles and parallel lines, Year 9 factorising quadratics, and Year 10 advanced tricks. So I'll show you my sequence plans at the end, and you can compare yours to mine if you've done one of these. Or if you'd rather spend this time doing something that's actually relevant to what you're teaching next, look at what you're teaching next week, or look at what you're teaching after half term, and try planning out a sequence of lessons for that. So like I did with the grid, where I say Monday, Tuesday, Wednesday, this topic, this topic, this topic, or not topic, but this strand or this concept, and plan it all out. And then you'll have a head start on your lesson planning that's coming up. I'm going to stay online. I will turn off my camera and I will mute myself, but I am going to be here. So if you want to ask me something on the chat, or if you want to unmute and speak to me, you can. And you can ask me for advice, or you can ask me questions if you want. You can send me what you've done by email if you want, or in the chat. You don't have to, okay? You don't have to send me what you've done. You can just come back at the end and have a look and compare it to my work, okay? So what I'm going to ask you all to do is come back here. You can either just stay on mute and camera off and do some work, or if you like, you can leave the meeting and rejoin the meeting. That's okay. But let's come back together at 12:15. I'm going to show you what I've planned out for these particular topics, and then we'll finish at 12:30. Right, hello everyone. I don't know if anyone's still there, but hopefully some of you are. I said we'd come back at 12:15. So yeah, all I can see is your little muted initials at the top. So I assume I'm talking to someone. Right. Hello. Thank you for staying here. I really appreciate that. I'm sure you'll remember what it's like when you're teaching online, and when you get these little responses in the chat, it's like, yay, lots of you are saying here. Hello. Oh, hello, Sarah. Sarah's sitting just down the corridor. Right. Thank you for going off and doing that. And actually, a couple of you did send me some things. We had Max sent me one that probably you would have seen if you were looking in the chat. If not, then have a look at what Max shared. Ben from Clapham has sent me an example of one of his sequences. And it's just amazing that me just looking, I literally just looked at two there. So I looked at Max's and Ben's because they sent me them. And already I was really interested in their order, and I was thinking about it. And it just, this is what maths teachers should do. We should sit together as departments when we have a new topic coming up, and we should talk about that ordering, and we should discuss it and pull it apart, and we should critique each other's orders or get ideas from each other's orders, because this is what, this is the best bit of maths teaching, is when we have time for this. And it's actually quite nice to have an insert where we just have a little bit of time for it. So actually, this is worthwhile stuff. Thinking about it individually, but also looking at other people's, really, really worthwhile. Right then, thank you to people that have said that hello in the chat, and I'm just going to be about another 10 minutes. We're just going to look at some my examples of these. They may be very different to yours, they probably will be, but that's okay. No two maths teachers will come up with the same sequence. Okay, now you may have gone off and planned something not on the list, but let's look at the ones on the list. So I said year 7 area and perimeter. What I'm going to show you is what I did with my year 7s last year. So this isn't some theoretical perfect way of teaching it. This is what I actually did, and I was under a little bit of time pressure. I didn't have quite as much time as I wanted, but this is what I did for year 7. So I started with some reasoning on the concept of area, and it's funny because I thought that's going to be really patronising for them, counting squares, but then I gave them some counting squares problems that they really didn't know how to do, like really challenging counting squares problems. So that's actually a great place to start. I then did some rectangles and L shapes, and MathsPad is just great. MathsPad basically taught this whole topic for me because the resources on MathsPad are fantastic. So rectangles and L shapes, plenty there. In fact, if I'd had a lower ability class, I'd probably done a separate one. Rectangles on its own. How could I do a whole hour on rectangles? Well, I could have had fractions and decimals as the side lengths. I could have done some working backwards. You know, if I give you the area, can you work back and find the sides? That kind of thing. But because I had a mixed ability middle class, so basically we have top set year 7, bottom set year 7, then we have a mixed middle. I did rectangles and L shapes in one lesson. What that then ended up with was me rushing L shapes quite a lot, because with L shapes, we all know you can put quite a high level of challenge into an L shape question. And I didn't have enough time to do a huge amount of challenge there. Then I did triangles. I talked about that earlier. I did a whole lesson on parallelograms, and there's plenty. Paul Rowlandson has a blog post on parallelograms, and you can see how you can do loads with that. Then I did compound shapes, so basically, you know, rectangles with triangles stuck on top and stuff like that. I did a whole lesson on perimeter. I wasn't sure if I'd be able to, but actually we'd already done algebra by this point, so that really brought in the simplifying, and it was interweaving with algebra. Then I did my last lesson, which was a sort of reasoning, working backwards, solving equations, all that kind of thing. And then I did an assessment at the end. There's probably a lot more I could have done here, and if you've done your own version of this, you might have totally different things in it. I didn't do trapezium because we do trapezium in year 8, but I could have done trapezium here. And there's other things I could have done. There's loads of stuff I could have done. Like I said, I was under a little bit of time pressure at this point, and I did 2 weeks on this. That's basically all I had. But I definitely had enough to fill 2 weeks. Like, that was easy to fill 2 weeks. For year 8 angles in parallel lines, it's really interesting because I'll talk to you that Ben from Clapham has sent me his version, and it's different to mine, but he's put some stuff in that I should have put in. So basically, I did 3 revision lessons on angles. I did one on angle facts. Oh, just bear in mind, this class had done angles in year 7 in lockdown. So they needed perhaps more revision because they weren't taught it well in lockdown. They just done it themselves on Hegarty Maths. We've got no idea. Half of them wouldn't have even done it. You know, we had no idea how much they'd done. So I put 3 revision lessons in on angle basics. One on angle facts, and that was like straight line, round a point, vertically opposite. One on triangles, and one on quadrilaterals. So I started with a whole load of revision. Then I started my angles and parallel lines proper bit. So I did a whole lesson on parallel lines and transversals, and just understanding the idea of why the angles as they slide down the transversal stay the same. If the 2 lines are parallel, those angles, you can move them up and down the transversal and they stay identical. They are congruent angles, and it's a really simple idea. So I did a whole lesson on that simple idea. They could at that point then work things out, but they didn't know any of their reasons. Then I did 3 separate lessons on reasons: corresponding angles, alternate angles, Carringteria. Okay, and most people combine those things. I tried this last year to do them separately. It did work, but I know they can be combined. Then I just did 2 general problem solving lessons. And just to mention that Ben at Clapham has sent me his version of this, and he had a specific lesson on, are these lines parallel? And I probably should have that in here. I probably did a bit of that in my problem solving lessons, but it's worth drawing attention to the fact that that is vital. Are these lines parallel? If these are the angles, are they parallel? I should have had that in there. And like I say, I probably did, but just not mentioned. He also had a specific lesson on quadrilaterals. Again, I would have put that in my problem solving lessons, but now I'm thinking I need to change this. I need to put in a lesson on quadrilaterals, because parallelograms and trapeziums are all about those parallel lines, aren't they? When you're, because students know the opposite angles in parallelograms are equal from primary school, but they don't understand why until they understand co-interior angles. So actually putting a whole lesson in exploring quadrilaterals and their parallel line properties is really important. So thank you to Ben for sending me that, because I didn't think of putting that in as a specific thing. But when you atomize this topic, that's actually really important. For my year 9 factorising quadratics, it's difficult. I had a quite low ability year 9 last year, so I didn't actually go very far into non-monics. But I'll show you now what we could do here. When I taught this last year to my year 9s, who they were set 3 out of 4, they struggled with the negatives. As soon as negatives came up, they had no idea. So they can factorise a quadratic when I say find 2 numbers that multiply to give that and add to give that. They can do that. But as soon as there's negatives, it was really tricky. So I think I should have started with revision of negatives. Then a bit of revision of expanding. And actually, my class, like I say, quite a weak class. I shouldn't say weak, you know what I mean. They needed practice of single bracket expanding and factorising. So remember what factorising meant. And then they needed a practice of expanding double brackets, a revision of that. They'd done it in year 8, but we revised that. Then I'm into my factorising, and I did the first lesson, monics, so A equals 1, with no negatives, because as soon as the negatives are in, then they lose all confidence in this topic. The next lesson, still monics, A equals 1, but putting some negatives in as well. Then, and I didn't do this with my class, but then I could go to factorising non-monics where A is greater than 1. In fact, I might even do 2 lessons on that. But like I say, with this particular class, I didn't do it. They were year 9. They will get the opportunity to do it again in year 10. Difference of 2 squares, really, really great questions you can do on that. If you see Don Stewart's difference of 2 squares questions, they are great. Really, you could do a whole lesson on that. Some mixed problems at the end, and then an assessment. So basically it's such a small thing, factorising quadratics. It's quite sort of self-contained. But yeah, there's still quite a lot you could do on it. You could do at least a week on it. And finally, on my advanced trig, now I included that because I'm teaching it at the moment, and I don't know the best order for this. And this is an order that I have suggested in a presentation I did before, but actually now I'm teaching it, I've changed the order up a bit. So I thought a recap of surds, a recap of right angle trig, and then exact values, deriving them and calculating with them. Because if you do the exact values at the beginning, then those exact values can come up when you teach sine rule, cosine rule, and half A, B sine C, which is quite nice. Some right angle triangle problems, just to make sure that they know how to use those exact values, and also some of those trickier problems go into a bit of depth. That's all recap. They did it in year 9, and then into your kind of non-right angled stuff. So half A, B sine C. Colin Hegarty does that first before sine and cosine rule, and why not? Sine rule, cosine rule, a bit of method selection. So should I use sine rule? Should I use cosine rule? That kind of thing. And then maybe some 3D trig and trig graphs, although we've decided we're going to push trig graphs to year 11. Actually, we're not doing that this year. So there's a whole load of stuff you can do here. If you're going into real depth, if you've got like a top set year 10 and you're doing sine rule, you should be doing the ambiguous case that in a sine rule question, it might be that there's 2 possible answers. That is depth. And that's quite challenging. And actually, you can't really do that well until you've done trig graphs, because otherwise you can't explain why there could be 2 possible answers. When I've taught this year, I actually changed the order. I did the non-right angle stuff first, and I did the exact values at the end. And in fact, I'm doing that tomorrow on Monday. I'm doing my exact value stuff. So you can see that there's a whole load of stuff we could do here, and I could add loads to this. This is actually quite rushed teaching because there's a lot of content here. So this is quite a quick version of what it could be. But look how much there is. So that is, let's see, 3.5 weeks. If you've got 4 hours a week like we do, that's 3.5 weeks. That's quite a lot. Now our scheme of work gives us 3 weeks, which is actually pretty decent. So 3 weeks for me to go through all this is about right. If I had less than 3 weeks, I would really struggle to get through this content. I'd have to cut stuff and basically say, right, my class just aren't going to get to do that bit because I just haven't got time. Anyway, that's all I wanted to show you in terms of my sequences. It'd be interesting to hear how your sequences compared, and I probably missed some stuff. I have got about 4 minutes left if there are any questions, but just to finish by saying, if you want to come and visit us at Harris Academy Sutton, you are welcome to. If your line manager approves, you can get in touch with us, and we're always happy to host people, come and watch some of our maths lessons if you're interested. Like I said, I am on Twitter. I've also got a Facebook account for my blog, so you can connect with me on there. But do kind of get in touch if you want to discuss anything. If you've got any questions now, feel free to ask either in the chat or by putting your hand up and unmuting. But if not, then you're welcome to go off and enjoy your lunch. Okay. Thank you very much for coming today.